we learned in this week about the behavior of matter as you change the temperature. We talked about both the behavior of the matter that you can see or observe, and then the model that underlies that. The model is what would cause that structure to be what it is. And so we listed temperatures just in a general sense. And so we said we would have there's a category of low temperature and a middle temperature, and then there's a high temperature range here. And then we had a physical state column. We didn't call it that in the notes, but that's what it is essentially, a physical state column. And as long as the temperature is low enough, for a substance, and it would depend on the substance how low it needs to be, you're going to have a solid. We said that solids actually come in two forms. Solids can be crystalline or amorphous. We did the other day. And if we were to look at the solid, we would say that the solid would have, let's see, it maintains its shape, or it keeps its shape, right? Isn't that what we called it? And if you want to be real specific about it, the way they do it in science textbooks, they say definite shape is the phrase. If you say keeps its shape, I'd probably count that for full credit. Okay? But you can do both. It's okay. Now that's the observable behavior. That's the behavior you can actually see, or you can observe. In this case, you see it. And if we go and try to find out, well, what's causing that behavior, what do we call that? The cause of the behavior. What category does that fall under? We just did it yesterday. What do we call that thing that will explain the cause of behavior in the sciences? A reasonable explanation for the cause of behavior based on good science. Huh? That's it. The word is model. That's a really important word. We learned it and used it a lot so far. You need to know about this thing called the model and what that means. Okay? So what model for the behavior allows solids to keep their shape?
Particles that wiggle around.
Well, that's not the whole thing. They do wiggle around, but the more important thing is what? They stay in place relative to each other. That's what's more important. Otherwise, they wouldn't be a solid. The key thing is they stay in place, but they do also wiggle. Okay, so they're vibrating, moving around, but they don't move around relative to each other. So they can sit and twist and turn, but they have to stay side to side, front and back, things like that, in place like that. So while the particles can twist or wiggle, they stay in place. How many of you got little brothers and sisters? Or little brothers or sisters, okay? And so when you tell them to stay there, do they stand like a statue? No, they wiggle like that. That's like the particles in a solid. They might stay in one place, but they wiggle and twist, don't they? Okay. No? You must have a special brother or sister. Everyone I've ever seen does that. All right, so the middle range then, if we raise the temperature enough, we're going to get what? a liquid. And when we observe a liquid, how can we tell it is a liquid? What kind of behavior tells us it's a liquid? It does move, but that's not the critical thing for finding out whether it's a liquid. We can move a solid.
When it takes up, like for example, the shape of a container, it has no color.
It takes up the shape of the, yeah.
It takes up the shape of the container, but so do gases. What's the difference?
It only takes up the container down and sideways.
Right. That's the key to the difference between solids and liquids. While both of them will take the shape of their container, but the liquids take the shape of the container only in a downward and sideways motion, okay, direction. So it takes the shape of the container, down and to the side. Okay? So what is the physical behavior of the particles then? The structural particles. This is all about structural particles. When we talk about models in the sciences, we're almost always talking about atoms, molecules, ions, electrons, and the atoms, ions, or molecules are the structural particles. What are the structural particles doing that make a liquid do what it does? Allow it to take the shape of its container down to the side. How are those particles put together? If you're reviewing your notes at the same time I'm going over this, you're doing the best you can to do well on this test.
No longer stay in place, they move around,
They move around each other but still touch, right? Okay, so the particles, the structural particles move around each other but still touch. And when I say still touch, that means that the solid particles also are touching. So solid particles wiggle, and it should be say wiggle but stay in place. Now I don't know where I got the from, but it should be wiggle but stay in place. Okay? They also touch each other. Okay, they touch each other, they stay in place, although they do wiggle around. Alright, so we got a substance that could be a solid. If it's cold enough, if you raise the temperature, you can get to be a liquid. If you raise it some more, it's going to be a
Gas.
And what can we observe about gases that would tell us it is a gas?
You take the shape of the container every way, up, down, and side.
Every direction. Okay, that's good. Takes the shape. Its container in every direction. Up, down, front to back, side to side. Okay, and what is the model for the behavior? How are the particles actually arranged to give it that sort of property we can observe?
They don't touch each other, just bounce off each other.
Yeah, they for the most part are not touching each other. They're flying around, not touching each other, and if they do touch each other, they just bounce off. So the structural particles, you could say, are flying around, not touching except to bounce off each other. Okay? Any questions about that part?